Let's talk a little bit about the lab from yesterday and what you have to graph and what you have to answer. So, here's the deal.
Oh, we have to graph 4 graphs?
Yes.
Wowzers. That's a lot.
Okay? You actually only have to do 2 if you think this through. Okay? So, what I would do personally if I were you all, okay? If I were you all, this is what I would do. You're going to have aluminum and water, and you're going to have the iron and water. So I would just have like a 1 water graph and put both sets of data on the same graph. If you want to do them all separately, you can. It doesn't make any difference. Now, here's what you have to watch. You only have 2 data points, okay? So you want to make sure that, number 1, you have very, very, very precise data. You also want to kind of spread this graph out as far as you can so that, you know, you're looking at something that's going to be pretty small. So you want this spread out. So what I would do, let me see your data.
No.
Okay, so if I'm looking at Hunter's data with the water, he's got the aluminum and he's got the iron. So both of his values of AGH, okay, are typically something, in his case, something times 10 to the 3rd, something times 10 to the 4th, okay? Same thing down here. So when you get those numbers, don't go, oh, here's 0 and 1, because of the fact that you're going to have such a small range of data. So if I'm Hunter looking at his going, okay, basically everything is 10 to the 4th, maybe 10 to the 3rd. So what he could do is come down here and go, okay, I'm just going to make everything 10 to the negative 3rd. That's going to save me writing 10 to the 0.0001, 0.00002, okay? And then if you want to do it this way, that's fine. And then come in here and go, okay, hey, this is going to be like, what? Then maybe spread this out all the way out here. Go, okay, here's 1 times 10 to the negative 3rd. Here would be, 2 times 10 to the negative 3rd. You'd have to look at what your data is, okay? So, but if you're going to start here at 1, keep in mind that if you're less than 1, then that's going to be like, in effect, 10 to the negative 4th. So you have to look at what your data is, okay? If you want to do it this way, great. If you're hardcore and, hey, I like to write zeros, fine, write zeros. But just don't go, oh, here's 0 and 1, because your 2 data points are going to be like this. And then you're going to try and draw 2 points that in between there that doesn't make any sense at all. So I don't care how you do the graphs. If you want to put, wait, at least wait till I get done. Okay? So if you want to draw 4 separate graphs, that's fine. But I beg of you, spread these graphs out so that you kind of see what you have going on. Now, are these lines going to give you the density of the blocks, or are they going to give you the density of the fluids? Kind of a key thing to understand.
It'd be the block.
There's only 2 options. Just take a guess.
Thanks for narrowing it down for us.
My one is the water.
So here's the deal. Okay, density of steel is pretty big. Okay, much more dense than water. Even the aluminum is more dense than water. So just when you look at, if you don't know what the answer is, just look at kind of what your data points are. Do a rough estimation of your graph. See what you get for slope, and then see if, kind of where you're at. Now, because here's the deal. If it's representing the aluminum and the steel, then both graphs should have, regardless of the fluid, the slopes for the steel and the aluminum should be the same. If it's the graphs are representing the density of the fluid, then it shouldn't make any difference whether I put steel or aluminum in here, because I'm finding the density of the water. Then the same thing is true of the ethyl alcohol. So one of two situations is going to be true. Either if you're finding the density of the fluid, both of these lines on this water should be the same slope. Okay? And the same thing with the ethyl alcohol, or at least pretty close. If you're finding the density of the material, then the steel lines, no matter where you graph it, or the iron lines should be the same, and the aluminum lines should be the same in terms of density. So that's what you want to look at. So when you find your slope, if you're not sure, oh, I don't know what that actually is, look at what your graphs are giving you, and then look and go, okay, what can I glean from this information? Now, on this lab, you have much to answer today. So you've got these 8 questions to answer, okay? Make sure that you do those on another sheet of paper. Resist the urge to collectively work with this. Think this through, okay? You're going to calculate on your data. You're going to find the slope. Everybody's slope is going to be different. Show me the calculations of the slopes, okay? Show me the calculations of the slope. Then,
How's everybody's going to be different?
well, in terms of each group. Yeah, no, not each individual. But now, you want to calculate the experimental error. The accepted value for the density of water is 1,000 kilograms per cubic meter. The accepted density for the ethyl alcohol is 792, which I have listed on page 2. Okay, so you're going to have 2 different experimental errors, with your experimental error just based upon that, just based on the average slope. Okay, so basically on the water, you're going to take the slope that you get, use that on your average, and the same thing with the ethyl alcohol. Okay. Now that other assignment is due tomorrow. Let me give you some hints on that one.
8.
Oh, let me see.
This one, or you want to see my work too? You can look at my work too.
Okay, so when you get to number 8,
Yeah.
Oh God.
Yeah.
Here,
you go ahead. Go.
no.
Just look it over too.
It's the answer seems so big. I had John.
not bad.
Not bad.
445. I have nothing. Okay. So you're okay.
That's
But you said
good.
the
But you said
Yeah, but your answer to G is wrong.
So,
Wait, what do you have on G?
G. Yeah.
Should be F.
Or F. I'm sorry.
yeah. Why did you do that? That bothered me
Okay,
too.
back off. All right.
God.
I took out a question and then forgot to renumber it.
You're better than that. Okay. I'm sorry.
Tell me, explain
What'd you
to me
get on
how
that?
it's wrong.
Negative
Okay.
3.87 times 10 to the third.
So,
I got that, but it wasn't negative.
It's FG minus FB.
It's it's FB minus FG.
okay, hold, just stop.
That's what we have.
Okay, just stop.
I wrote that in my notes, by the way.
Just stop. Okay.
So I can.
Just, up.
Stop.
So,
Please, just let me be. He doesn't stop touching me. He just has to do. Thank you.
here's the water, right? And you're submerging this piece of copper down here. Okay? Is there going to be a buoyant force even though it sinks?
Yes.
Which direction is it going to act? Up. Upward. So my buoyant force is going to be acting up, right? Which direction is gravity going to be pulling? Down, right? So since this sinks, which one is bigger?
The
FG is, right? So that means my tension has to then be acting upward, right? So if you're going to define up as being positive, that means I want my entire net force to be 0. So in this case, my tension plus my buoyant force minus my FG is all going to equal 0.
Why is that?
Because these two are the ones that are acting
That's
up.
so simple, bro.
Okay?
How'd you guys get that wrong?
Oh, shut up.
How far are you on?
So, if you're to define these two as being positive, okay? So, when you look at this, okay? Since this plus this minus this has to equal 0. That's why that tension has to end up with a positive sign.
Okay, so in what scenario would FB minus FG equal T?
So let's say that you're trying to hold a ping pong ball underneath the water. Okay? You're going to have more buoyant force acting up than you do gravity acting down. Bless you.
Thank you.
So which direction are you going to have to apply a force to keep that ping pong ball from floating up?
Up, down.
Down.
So then your tension is going to be acting down. So now your tension plus your Fg has to equal your buoyant force.
Okay.
See the difference between the two?
Yeah, so it's the same answer, just positive.
Yeah, but it's kind of a big, because if you make it negative, it's like you're saying that you're pushing it down.
Yeah.
Yes?
So is 8A like kind of like, because I just thought that was kind of big. Is it 445?
Yeah.
I just feel like
It's
it's a very small volume.
0.05 cubic meters isn't all that small.
Yeah, that's like almost a gallon.
Oh yeah, I was forgetting. Yeah, never mind.
Mr.
It's not like a gallon, but yeah, okay. Yeah.
It is.
I'm just thinking about it wrong, yeah.
Okay.
0.05 is almost a gallon.
Now, let me kind of take you through what's going to happen on number 10.
Okay, good.
Okay? When you get to number 10, so here's the steel, right? What are you given about the steel? What information are you given?
The mass.
Mass.
Yeah, so you have the mass of the steel, and that's it, right? But are you in salt water or are you in fresh water?
Fresh.
You're in fresh water. So, what are the three forces that are acting on this steel plate?
The
crane.
force of the crane and
So you have the tension acting up, right?
and force buoyancy,
You have the buoyancy force acting up,
and then force gravity.
and you have gravity acting down, right? So clearly, which is bigger, your buoyant force or your gravitational force?
Gravitational.
Yeah, that's why you need to lift it up. That's why you need the crane, okay? So here's the deal. So look at this going, oh, okay, well, I know how to handle this one. So if I take my buoyant force plus my tension, those two together have to add up to equal my Fg, right? You want to look at it this way. So the gravitational force is going to be simple. You have the mass of the steel and you know what G is. Okay, that's simple. Tension, that's what you're going to solve for. The buoyant force is where this gets weird, okay, but not bad.
Oh, okay.
So what do you need to calculate the buoyant force?
Density of the water between
You need the density of the fluid.
Need
What else do you need?
little g. And
Little g.
I forgot
Sounds
the
like a
name.
rabbit.
Oh,
Oh,
yeah.
yeah.
Fun
Little
displays.
g.
Little G.
Fun
Little
displays.
G.
Little g.
Fun displays.
Little g. There we go. Okay. It's gonna get a wee bit dodgy. All right. So I need to find my volume. So how can I find my volume, Holly?
Water
You
displacement.
could do density times mass.
Yeah, no.
That's not your name?
Is that right?
Dodgy.
Can you do like the density equals
Water,
mass
water
over volume?
Ew, brilliant.
Yeah, wait.
Density is mass divided by volume.
Oh.
Ew,
Water.
rightio. Now, which density do I use?
Density of the thing.
The
British.
density of the thing.
Steel.
A Scottish thing? Or a British thing? Or an Australian thing? It's the steel thingy.
Big, right? The steel
Oi! Can you look and find the density of steel?
Yes.
Yes!
Oh my god.
Oi! Do you know the mass of the steel?
Is that a D or a
Yes.
P?
It's a row!
So is that density?
Cheese.
Why can't you use D?
Row V G.
It's Row VG.
It's a bloody row!
What does that mean? So D!
What? Oh my gosh.
So to find the
Okay.
volume,
Radiel.
you take the end of that.
How can I get
D equals MV.
V by itself?
You multiply by V divided by P. I'm gonna
Divide it.
So V is going to equal M over rho.
Yeah.
You know the mass of the steel? Boom. There you go. Now, if you really want to get fancy, ooh, you really want to get fancy.
Now we need to watch this.
Okay, so let's go fancy. So we'll take, we want to solve for tension, right? So tension is going to equal Fg minus buoyant. This is going to be the mass of the steel times G. This is going to be the density of steel, density of water.
Water.
There you go.
Now, for the volume of the water that's displaced, you can come in here and go, okay, that's the volume of the steel, which is going to be, in this case, if you flash back, that's going to be the mass of the steel. Oh, wrong way. The mass of the steel divided by the density of the steel times. Now, this is if you really wanted to get dodgy. What's a common factor?
G.
And?
Yeah,
So if you really wanted to get fancy, you could go, oh, that's 1 minus rho of water divided by
yeah, I'm not gonna get that one.
rho of steel. If you really wanted to get fancy.
Don't worry
Nope,
about it,
I'm
guys.
just telling you.
Nope, I don't want to do it. I'm
I'm
not
just
going to even
telling
write it
you.
down.
Thanks for
I'm not doing
Thank you for that, though. That was a nice little break.
Just trying to be helpful. You know.
So for the one before it.
Okay.
Go back a slide. Oh, a button.
Whatever does it for you.
Thank you.
Now, nice paper.
Wow. Yes, sir.
When you get to question number 9, okay? When you get to question number 9,
Why did you do 10 first?
because somebody asked about 10.
But you knew you were gonna tell us about 9. You should just did it. I'm sorry, go ahead.
Oh my gosh.
But now I don't know where to space it out and put 9 for the notes.
We'll just put notes.
Yeah, to be honest, I kind of filled up the bottom
So you put-
with 10.
Just number them.
Now,
Having more
now,
research, that's
There's
what
a backside!
Then I gotta lower your voice.
of what?
You're inside.
Really?
him
Hadn't figured that one out.
Yeah, I'm
3
pretty
years, I
obvious.
hadn't figured out I was inside. Wow.
The tension
Okay,
in
I've
this
been
room
doing
is
something all this time I didn't need.
Hey, it has to be positive.
Okay. So here's the deal. Here's the fluid. Anytime something floats, what are the only 2 forces?
Points.
Buoyancy is,
Fg and
FB.
Fb.
and they balance out to equal 0.
Well, just set them equal to each other, okay? But here's the whole trick to this. That Fg is going to equal Fb. This is going to be Mg. This is going to be rho Vg. So right away, what can you do with your G's?
What is that a G?
Cancel that out.
Yeah, those are just going to cancel out. Okay? But now, this mass, right? You're not given the mass. How can you find the mass of the aluminum block?
If you know the density and volume.
So that's going to be the density of the aluminum times the volume. Now, is this volume the entire volume, the part that's below, or the part that's above?
The part that's below.
Above.
The whole thing.
It's going to be the whole thing. The whole thing is going to make up that mass. Because this is my FG, right? So this is the entire density of the aluminum times the entire volume of the aluminum.
I agree.
To find the entire mass.
Mass.
Okay, that makes
Which is
sense.
what's and that entire mass is going to be pulled down by gravity.
So M equals.
It's. Just go.
Wow. What a
Now,
concept.
What's going to create my buoyant force? Density of the fluid.
Times the volume of the fluid.
What volume do I use over there? Volume above, volume below, total volume.
Volume below.
Yes, because that's the volume that's displacing a liquid. So this is going to be the volume that's submerged. Just like yesterday, work it out as a ratio. Okay? All right. I am done. You have the rest of the time to work on the assignment and work on the lab. Yeah?